Hello everyone, hope you're all doing great. In this video, we are going to discuss about placental functions. Placenta functions. Basically, if we see, these are the villi of the placenta. Okay, we have the intervillar space over here, which is consisting of the maternal blood, and in the villi, we have the fetal blood. So what is happening here is the blood from the maternal blood and the fetal blood are passing like this side by side but in opposite directions. So in this region there is an area of exchange. So commonly any nutritive substances or oxygen that are needed for the growth of the fetus are traveling in this direction, and excretory products from the baby is going to travel into the maternal circulation in this direction. Okay. We'll see all the functions one by one. First function is a respiratory function. So in respiratory function, what is going to happen? Oxygen is going to travel from the mother to the fetus, and carbon dioxide is going to travel from the fetus to the mother, and the rate of oxygen supplied to the fetus is around 8 ml per kilogram per minute, and this oxygen supply happens by simple diffusion. Okay. Next function is the excretory function. Basically, the excretory products from the fetus, namely the urea, uric acid, creatinine, are going from the fetus to the mother, and this also happens by a process of simple diffusion. Okay. Next we will see the nutritive functions. First one is the glucose. Glucose is transported by facilitated diffusion. There are GLUT1 and GLUT3 receptors present in the terminal villi. Placenta itself stores glucose and acts as a reservoir. Next one is amino acids. Amino acids can be transported across the placenta by active transport. Proteins are produced in the placenta. In the first trimester, it is around 1.5 gram per day, and in the third trimester, they are produced at a rate of 3.5 gram per day. Regarding lipids, both maternal and fetal lipid transfer occur, and this occurs mostly by a direct transfer. Whatever the type of lipid, say triglycerides, cholesterol, fatty acids, all these things are transferred directly, and essential fatty acids are transported more when compared to the non-essential fatty acids. Water transport also occurs. Then electrolytes are also being transferred. Electrolytes like sodium, potassium and chloride are transferred by simple diffusion. Whereas calcium, iron, phosphorus are transported by active transport. Vitamin transfer also occurs. Water soluble vitamins are transported by simple diffusion. Fat soluble vitamins are transported but at a much slower rate. Placenta also acts as a barrier. Okay, so more than 400 daltons of molecules are not allowed to pass through the placenta usually, but there are always exceptions to any rule, right? So the antigens and antibodies are transported through the placenta, especially IgG antibodies. Remember, G means goes. So IgG goes through the placenta. Also, any antigens, let's say drugs or any infectious causes like measles, mumps, chickenpox, rubella, tubercle bacilli, okay, all these can cross the placenta. And regarding antibodies, only G goes through the placenta. Suppose if there is a IgM antibody in the fetus, it has occurred due to infection. Okay. And also, remember, IgA antibodies are not usually seen in the fetal life. It is produced only after the child is born, that is in the infant life, when the enteric infections occur. Next is about the immunological function. So, anything antigenic to the human body is rejected, right? Now, this placenta is getting attached itself to the uterine wall. So, it should be ideally rejected, but it's not happening. How? See, we have two types of trophoblasts, say villus trophoblasts and extravillus trophoblasts. Villus trophoblasts does not express class 2 HLA antigens. Now we will see the immunological function. Basically, trophoblast cells do not express class 2 MHC antigens. We will see the immunological function. Trophoblast cells don't express class 2 MHC molecules. Trophoblast cells do not express class 2 MHC molecules. So basically, these cells are not presented to the maternal CD4 plus T cells. Okay. For better understanding, if you see, we have villus trophoblast and extravillus trophoblast. Okay. So, villus trophoblast does not contain any class 2 MHC molecules. In extravillous trophoblast, we have only HLA, C, G and E. HLA, A and B are not expressed. These are very important in antigen presenting. Okay. So, all these factors prevents from immunological reaction to the placenta. Also, you have to know about the uterine natural killer cells. So, these cells are present in the decidua and they are very important during implantation and early development of the placenta. Especially in the trophoblast invasion and spiral arterioles transformation. Okay. So, what happens is we have the spiral arterioles. Okay. So, these spiral arterioles initially in the maternal circulation are a high resistance system. Now, this has to be invaded by the endovascular trophoblast. Okay. As it is invaded by the endovascular trophoblast, this high resistance system will be now converted into a low resistance system with the pressure around only 70 to 80 millimeter mercury. Okay. So, how this concept is applied? This low resistance system permits transfer of blood from the mother to the fetus. Okay. So, there is invasion of the trophoblast into the spiral arterioles and this invasion happens in two phases. Okay. The first phase happens up to 12 weeks of pregnancy where the invasion is up to decidua. The second phase of invasion happens after that, especially during 24 to 28 weeks, where the invasion happens up to the myometrium. Okay. Suppose for any reasons the second phase of invasion is not happening, then it can lead to uteroplacental insufficiency that can result in conditions like pregnancy induced hypertension, IUGR, etc. Next we will see about Hofbauer cells. Hofbauer cells are round macrophagic cells they have a phagocytic action. They are present in the decidua and they express class 2 MHC molecules. So, they trap the maternal antibodies that is coming through the placenta. Okay. Now, we will see the endocrinological function of the placenta. We have numerous hormones that are produced from the placenta. Okay. So, the hormones produced from the placenta can be classified into two types, namely the steroid hormones and the peptide hormones. Steroid hormones include estrogen, progesterone and corticosteroids. Whereas the peptide hormones include human chorionic gonadotropin, human chorionic somatomamotropin, vascular endothelial growth factor, platelet derived growth factor, insulin-like growth factor, corticotropic releasing hormone. We will see one by one. First, estrogen hormone. We have three types of estrogen, okay, namely estradiol, estradiol and estriol, which are E1, E2 and E3. We will see about estrogen. There are three types of estrogen, namely estrone, estradiol and estriol, okay, which are E1, E2 and E3. Estrone is specifically seen during menopause. Estradiol is more commonly seen during reproductive life. Estriol is seen during pregnancy. So, if you ask me which is the most specific type of estrogen in pregnancy, then the answer is estriol. Okay, but if the question is what is the most common estrogen found in pregnancy, then the answer is estradiol, which is E2. I want to tell you one thing, that placenta as itself doesn't produce estrogen because placenta lacks the enzyme 17 alpha hydroxylase. Okay. So, remember this enzyme is absent in the placenta. This enzyme is absent in placenta, which is required for estrogen production. Now, where does the estrogen comes from? It comes from the fetal adrenal gland. Okay. Fetal adrenal gland has It comes from the fetal adrenal gland. From fetal adrenal gland comes dihydroepiandrostenedione sulfate. Okay. So, it is dihydroepiandrostenedione sulfate. Now, this is going to cross and come to the placenta, where it will be acted upon by various enzymes, namely sulfatase, aromatase, etc. and then it will be converted into estrogen. Okay. Now, what is the functions of estrogen? Estrogen has various functions during pregnancy. First one, it helps in growth of the uterus. And how does the growth of uterus happen during pregnancy? It is hypertrophy more than hyperplasia. Second one, it causes gallbladder stasis. Then it is also responsible for hyperpigmentation that is happening anywhere during pregnancy. For example, melasma. It is also responsible for salt and water retention. Also, estrogen increases the oxytocin receptors in the uterus at term, and this oxytocin is going to produce contraction of the uterus and help in delivery. So, whenever estrogen is absent, it can lead to post-term pregnancy. Okay? We have a condition called placental aromatase deficiency. So, this aromatase enzyme helps in conversion of androgens to estrogens. Okay? When this aromatase enzyme is absent, what happens? Estrogens are going to reduce and androgens are going to increase. So, since estrogens are reducing, this results in post-term pregnancy, and since the androgens are increasing, in the fetus there is ambiguous genitalia, and in the mother also this is seen as hirsutism. Next hormone is progesterone. Progesterone hormone is produced from cholesterol, especially the maternal low density lipoproteins. Progesterone in early gestation up to 8 weeks is produced by the corpus luteum of pregnancy, and after 8 weeks it is produced by the placenta. What are the functions of progesterone? Functions include uterine relaxation. Okay, so it causes smooth muscle relaxation. It keeps the uterus relaxed. It also has anti-inflammatory action and immunomodulating action. Suppose if the progesterone hormone is not produced or it is decreased in conditions like luteal phase defect, what happens is there is uterine contraction in early gestation that can result in miscarriage, and in later gestations that can present as preterm labor. So, in any condition, if the woman is presenting with complaints of preterm uterine contractions, then we can give her progesterone supplement. Now, we will see the peptide hormones. First hormone is human chorionic gonadotropin. These are basically produced by the syncytial trophoblast There are two subunits in HCG, namely the alpha subunit and beta subunit. If you see, the alpha subunit is similar to various hormones like luteinizing hormone, follicle stimulating hormone and thyroid stimulating hormone. It is basically produced by the syncytial trophoblast cells. If you take HCG, there are two subunits, namely the alpha subunit and beta subunit. Alpha subunit is similar to luteinizing hormone, follicle stimulating hormone and thyroid stimulating hormone, and it more closely related to luteinizing hormone functionally. So, the most closely resembling hormone similar to HCG is the luteinizing hormone. Beta HCG is specific to this hormone in pregnancy. So, using beta HCG only, we do all the diagnostic tests. HCG has a half-life of 36 hours. What are the functions of HCG? It helps in maintenance of corpus luteum. It brings about smooth muscle relaxation and it prevents rejection of the fetus. HCG normally increases in maternal serum 5 to 6 days before her missed menstrual period itself. That means it is 21 to 22 days of cycle and 8 days after fertilization. Okay. Next hormone we will see is the human chorionic somatomamotropin. It is also known as human placental lactogen previously, but this lactogen is not related to any breast milk production activities. Okay, so this is a misnomer. Human chorionic somatomamotropin is also produced by the syncytial trophoblast cells, and this production starts from 3 weeks itself and it keeps on increasing and the maximum level is seen around 36 weeks. Functions of this hormone includes, it has a functions of this hormone. It creates an insulin resistant environment in the mother, and it is also causes lipolysis. Okay. So, since insulin resistant is brought from the mother, what happens is most of the carbohydrates from the mother are going to be transported to the fetus through the placenta, and it also causes lipolysis, thus providing energy fuel to the mother. So, as we have seen, HPL is going to increase throughout the pregnancy, right? Now, at this mid-gestation only, we have to check for this insulin resistance especially. So, that is why GDM screening tests are mostly done around this period. Next hormone is vascular endothelial growth factor and placental growth factor. Both these hormones act as vasodilators and also does help in the process of angiogenesis. Now these two hormones are opposed by one hormone, that is soluble FMT like tyrosine kinase. So what happens? There is vasoconstriction and angiogenesis is not happening. When these are not happening, this can lead to a state of uteroplacental insufficiency in conditions like pregnancy-induced hypertension and FGR. So, this hormone can be used as a marker in these conditions. Next hormone is insulin-like growth factor. We have insulin-like growth factor 1 and 2. And these hormones are important for growth of the fetus. Most important hormones for fetal growth. Next hormone is corticotropin releasing hormone. If you take this hormone is produced by the placenta in response to maternal glucocorticosteroid. So, whenever maternal glucocorticosteroid are increasing, this will produce more placental corticotropin releasing hormone. Now, this corticotropin releasing hormone is going to act on the fetal HPA axis and it will produce preterm delivery. Okay. See, normally also this placental CRH is being produced, but what happens is till term these CRH here are going to bind to their binding proteins respectively. But at term what happens? The CRH binding proteins are going to reduce. Okay. So, CRH usually passes through the placenta at term and this stimulates fetal HPA and it results in delivery of the fetus. This is what normally happens. When there is any stress, this cycle is going to start earlier and it will result in preterm delivery. I hope you would have understood all the placental functions, the various respiratory, excretory and the hormones produced by the placenta also. Until we meet in the next video, take care, happy learning and bye-bye.